All right, so this video is going to go over the remainder of your semester 1 exam. So this is all the stuff that was prior to Newton's laws. So we're going to start on a position versus time graph. So a couple things is your y-axis is your position. Okay, so it's gauged in meters. It's where you're at. And your x-axis is your time. Another thing to know is that slope on a position versus time graph equals velocity. Okay, so when you're looking for, if I ask you for anything on velocity, all you got to do is find the slope. Okay, if you want to find that, remember it's y2 minus y1 over x2 minus x1. So number one says the starting position of the object. That's just where did you start on the y-axis. You started right here at 0 meters. So that is your answer there. Number two, the position of the object at 1 second. So all you got to do is find out where you are on the y. Okay, so at 1 second, I'm right here. Okay, so that's going to be 4 meters, and that's all you got to do for position. Number three, the velocity of the object at 4 seconds. So at 4 seconds, you're right here on this line. Okay, so don't try to connect these points here and try to do velocity there. That would be average velocity. Okay, so, but we're not looking for that. I just want to know what is the velocity at that point in time. So wherever it falls on the line, I'm just going to find the slope of that line. Now, the way I usually do that is I usually pick the endpoints because those are nice whole numbers. Okay, so if I have endpoints, I'm going to have 3, 6 for this first one. And then I'm going to have 5, 4 for the next one. Doesn't matter to me what points you pick as long as you pick 2 points on that line. So we're going to do y2 minus y1, so 4 minus 6 over x2 minus x1, so 5 minus 3. Okay, and that's going to give you negative 2 over 2, which is going to come out to be negative 1 meters per second. The velocity of the object at 8.5 seconds, so 8.5 seconds, you're right here on this flat line. So you have no slope, so therefore your velocity is going to be 0 meters per second. Now displacement is just your change in position. That's just what's your change in y-axis. Where did you end versus where did you start? It's basically your final position minus your initial position. So at 8 seconds, I'm right here, I'm at negative 10. So negative 10 minus, where did I start? I started at 0. So negative 10 minus 0 gives me negative 10. So that's all you had to do there. Now average velocity from 0 to 10 seconds, that is where you connect the 2 points. So you have your point here, 0, 0, and at 10 seconds you're right here, which would be 10, negative 6. So you're basically finding the slope of this imaginary line that connects those 2 points. So you're still going to do y2 minus y1 over x2 minus x1. So negative 6 minus 0 over negative 10. I'm sorry, 6 minus 0. Nope, in this case, yeah. So 6 minus 0, my apologies on that one. So, and then, sorry, so it's 10 minus 0. That would be your time, so that shouldn't be a negative there. My apologies now. So 10 minus 0, I was trying to catch that. So negative 6 minus 0 equals 10 minus 0. That's going to give you negative 6 meters per second. 7, the time interval of the object is not moving, so that's when you're looking for flat lines. Okay, so it looks like from 2 to 3 seconds, and then 8 to 9 seconds. That looks like the only time there's a flat line. So that's all you got to do there. The time the interval is moving in the negative direction. So anytime you're going up on a graph, so like here, here, okay, that means you're going in a positive direction. Okay, anytime you're going down on the graph, so basically from 3 all the way to 8 seconds, that is when you're going in the negative direction. Okay, so that's all you got to do for position versus time graph there. Now, going on to a velocity versus time graph. Okay, so this is where you got to be careful here. Velocity versus time graph, slope equals acceleration now. Okay, so you're still going to do y2 minus y1 over x2 minus x1, but now your y-axis is your change in velocity, and x-axis is still time. So what is the velocity at 1 second? So if I'm asking for velocity, you're not looking for slope now. You just want to know where are you on the y-axis. So at 1 second, I'm right here. So that would be at 6 meters per second. Okay, what's the velocity at 6.5 seconds? So I'm right here. Okay, this is, sorry, it's kind of bad ink. It goes down by 2s. It goes negative 2, negative 4, negative 6, negative 8. So you would be at negative 6 meters per second. The acceleration of the object at 4 seconds, so now we're looking for slope. So at 4 seconds, okay, it's not 0. That would be your velocity. Okay, but we're going to do the same thing we did in the graph before. We're going to find the slope of this line. So you can use any points you want. Okay, I'm going to use the point 4, 0, and then 3, 2. Okay, so I'm going to do y2 minus y1, so 0 minus 2, over x2 minus x1, 4 minus 3. That's going to give you negative 2 meters per second squared. So the acceleration at 1.5 seconds, so now we're going to find the slope of this line. Okay, so it doesn't matter what point you use. I think for mine I used 2, 2, and then 1, 6. Doesn't matter to me as long as we get the same answer. So you're going to do 2 minus 6 over 2 minus 1. You get negative 4 meters per second squared. The time interval of the object is moving in the positive direction. So anytime you're above the x-axis, so remember your x-axis is right here. Anytime you're above that, you are going forward. So even though it can be pointing down, that just means you're slowing down. But anytime you're above the x-axis, you're going forward. Anytime you're below the x-axis, you're going negative. Okay, so when are you going in the positive direction? That would be from 0 to 4 seconds. The time interval you're going in the negative direction, that's going to be anything past that. So it looks like 4 all the way to 9 seconds. Okay, so 4 to 9 seconds would be when you're going in the negative direction. The time the object is stopped, that is when your velocity is 0. Okay, the only time that happens is when you touch the x-axis, and the only time that ever happens is at 4 seconds. The time interval, the object has an acceleration of 0, so therefore your slope is gone. There is no slope. Acceleration is 0, so there's no slope. So that looks like it'd be 0 to 1, 2 to 3, 6 to 7 seconds, and then looks like that little last bit, 8.5 to 9. So you're just looking for flat lines there. All right, now let's go on to the actual calculating stuff. So this is going back to basic kinematics. So I know you've learned a lot of stuff since then, but this is going back to basic Daffy T when you were learning. A truck is traveling at 8.0 meters per second, accelerates at 5 meters per second squared for 3.0 seconds. So there's velocity, there's acceleration, and then there's time. What is the displacement and final velocity? That means this 8 was our VI. So part A means we're looking for displacement is our D. So we're just going to do Daffy T. So Daffy T. So VI is going to be 8. A is going to be 5. T is going to be 3. We're looking for displacement, so that's your question mark is D. So that means we did not care about VF. So we're going to use equation number 3, which is going to be the whole D equals VIT plus 1/2 AT squared. So we're going to start plugging in. So 8 times 3 plus 1/2 5 times 3 squared. And you should get 46.5 meters, and that's all you had to do there. Now part B is we're going to do the same thing. We're just going to do Daffy T again, but we're just going to flip-flop. Now we're actually looking for VF. A is still going to be 5. VI is still 8. Time is still 3, so therefore distance didn't matter. So we're going to use equation number 1. So VF equals VI plus AT. Okay, so we're just going to plug in. So VI is going to be 8 plus A, which is going to be 5, times 3. We're going to solve for that, and you should get 23 meters per second. Number 2, a ball is thrown upwards at 14 meters per second. What is the ball's max height? Now, this is technically a projectile, but this is kind of just basic stuff. We're not doing any angles yet. Okay, so we're looking for max height, so that means you're looking for displacement. So we're going to do Daffy T again. But now we're throwing something, so gravity's back in the mix. So gravity is A is going to be negative 9.8. Okay, when you throw something up, when it reaches the top, remember your velocity has to come to a stop. So VF is going to be 0. VI is going to be 14. Okay, that's what you threw it up with. We don't know the max height, so you're looking for distance. That means we did not care about time. So you can use equation number 5. So VF squared equals VI squared plus 2AD. So 0 equals 14 squared plus 2 times negative 9.8 times distance. Move that 14 squared to the other side and then divide both sides by negative 19.6. And you should get a distance of 10 meters, and that is your height. Now, the part B, it says time. We're going to do the exact same Daffy T step. Now just switch these two. Okay, so now we're looking for time. We don't care about distance. Okay, so you're going to put a line through distance, which means we're going to use equation number 1. So VF equals VI plus AT. So 0 equals 14 plus negative 9.8 times T. Okay, so now we're going to solve for that t, and that's going to give you 1.43 seconds. Now this is where you got to be careful is this will give you the time it takes to get to the top. Okay, because your final velocity is 0, that means you've reached the top. Okay, now if I want to know the total time it's in the air, all you got to do is just multiply this by 2, and you get a total time of 2.86 seconds. Okay, so just watch out for that. C, what is the velocity when it strikes the ground again? So remember, whatever velocity it has going up, so in this case it was 14, is going to be the exact same when it comes down, it's just negative. So that would be your answer right there, would be negative 14 meters per second. Number 3 here, underline all the following that are vector quantities. So remember, vector means there's direction involved. Okay, scalar is something that does not care about direction. So speed is scalar, temperature is scalar, displacement is vector, distance is scalar, velocity is a vector, force is a vector, mass is scalar, energy is scalar, acceleration is a vector, and time is scalar. So again, vector has to have direction. So you really need to pay attention to just those 4. Everything else is pretty much scalar. The car is headed at 25 meters per second at 35 degrees west of south. What are the south and west components of the car's velocity? So I'm going to do is I'm going to draw my little T-chart here. Well, not my T-chart, my directional thing. Okay, so north, east, south, west. Okay, so we're west of south, so I'm going to draw a line here. So remember, whatever the last one is, south, that's the line that the angle line is touching. So it has to touch south and go west of it. So that means this is my triangle right here. Okay, so that means my hypotenuse is 25 and my angle is 35 degrees. So we're looking for the south component and the west component. So west component would be my x here. My south component would be my y. So you're looking for sides of a triangle. Okay, so x would be your opposite. So remember, sine of your angle equals opposite over hypotenuse. So sine of your angle, so sine of 35, equals opposite over hypotenuse. So that's going to give me my west component, x, over my hypotenuse is 25. Just make sure you're in degree mode in your calculator. So you should get 14.33 meters per second, and that is going to be west. Okay, so that helped me find my x. Now I'm going to help me find my y by using the other one. Okay, y would be your adjacent side. So this would be your adjacent. X would be your opposite. Okay, so cosine is going to help me find my adjacent. So cosine of 35 equals y over 25. Multiply both sides by 25. And we're going to get 20.48 meters per second south. Okay, so you're just using sine and cosine to break those up. Number 5, a person is walking at 2 meters per second on a moving walkway that has a speed of 3 meters per second. What is the speed of the person as witnessed by a stationary observer off to the side if the person is walking in the same direction as the walkway's motion? Okay, a lot of stuff there for some basic math. Okay, that means the walkway is going this way at 3 meters per second. The person is also going this way at 2 meters per second. Okay, so that's ultimately they're gonna combine. So that means ultimately the velocity will be 5 meters per second that way. Now it says, the next part says, what if they're going the opposite direction? So now we'll just say the walkway is still going this way, 3 meters per second. But now the person's going this way at 2 meters per second. Okay, walkway is going to win on that one. Okay, so they're going to subtract those. So it's going to be 1 meters per second. Okay, and ultimately you're going to end up going the way of the walkway. Okay, so it just depends on how you draw that. There is no, as long as it matches up, you could have said walkway was going left and the person's going right. Doesn't matter as long as you can show that. Number 6, what would the person's distance traveled in 4 seconds in the previous question while walking against the direction of the walkway's motion? This is just a basic V equals D over T. Okay, my velocity was 1. Okay, and my distance I don't know. Time is 4. Multiply both sides. So that means ultimately you ended up 4 meters that way. Okay. Number 7, for 2 vectors to be independent, how do they need to be oriented? They need to be perpendicular. That means up and down does not affect left to right. Okay, so when you're doing things like this, like the boat problem, okay, the river does not affect the boat's time crossing the river. Okay, they're perpendicular, so therefore they do not affect each other. So you're looking for perpendicular there. Number 8, a canoeist points his canoe directly across a 60-meter wide river and paddles until he reaches the other side. If you paddled at 6 meters per second, the current of the river is 3.2 meters per second. How far downstream did he end up? Okay, so I'm going to draw this out. And then again, it doesn't matter which way you draw it. I'm going to say the person's trying to go across at 6 meters per second. The river is going downstream at 3.2 meters per second. So the path's going to look like this. And my river is 60 meters wide. So we want to know how far downstream did you go. So you're looking for distance going this way. Okay, in order to do this, remember when we did these, all you needed to know was V equals D over T. Okay, so I have my velocity, but I don't have time. I don't know how long he's actually going to be paddling for, but I can solve for how much time it's going to take because I know my velocity going across the river, and I know how far the river is or how wide it is. So I'm going to use the velocity of the boat. So 6 equals 60, which is the width of the river, over time. So swap those two. So 60 divided by 6, and you're going to get a time of 10 seconds. Now you know the time. So now you can do your V equals D over T. 3.2 equals D, I don't know, and my time is 10 seconds. So that means when they hit the bank on the other side, they were pushed 32 meters downstream. Okay, now it says, what is the velocity relative to the shore? Find the resultant velocity. That just means we're looking for this angle right here, and we're looking for the hypotenuse. Okay, so the resultant is basically just the resulting of both horizontal and vertical. So if you know both sides of a triangle, all you got to do is a squared plus b squared equals c squared. So the square root of a squared plus b squared. So 6 squared plus 3.2 squared. And you get 6.8 meters per second. So there's your magnitude. Now we just got to find our direction. So we know our opposite's 3.2. We know our adjacent is 6. So the only one that uses opposite and adjacent is tangent. Okay, so remember you got to do inverse tangent of opposite over adjacent. Okay, so you're going to do that 3.2 over 6. And we're going to say it comes out to be 28.07 degrees. Now, I went north here and east. Okay, so you can kind of use whichever way you went. So ultimately, mine went east of my north line. Okay, so because my angle is touching that north line and then going east of it. Okay, so remember, whatever the last letter is, that is the line that the angle line is touching. Okay, so but you could run your different. Okay, as long as we're basically looking for the magnitude and the angle to see if you're correct there. Number 9, if the boat in the previous question turned and headed in the direction of the river, what would the boat's maximum and minimum velocities be? So that means if the river is going this way at 3.2, and now the boat's going this way at 6, well, what's going to be the new velocity? It's going to be 9.2 meters per second this way. Now, if the river's still going this way at 3.2, but now the boat's going this way at 6, okay, they're not going to help each other, they're going to hurt each other, so subtract them. So it's going to come out to 2.8 meters per second, and then ultimately the boat is still going to the left. Okay. So moving on to the next one, projectile motion. Okay, so remember projectiles is you have type 1, which is something rolling off a surface. So that's type 1. And type 2 is when you launch something at an angle. Okay, so number 10, a hockey puck slides off a table horizontally with a velocity of 6 meters per second. If the puck hits the floor in 0.53 seconds, how high is the table? So this is type 1. So remember I said the easiest way to kind of do this was to do a T-chart. Help organize your X and your Y. So remember Vx, Dx, and T. Those are anything horizontal, those are only 3 things that matter. And then anything vertical is Daffy T. Okay, this is a type 1 problem. So it says that the puck slid off horizontally with a velocity of 6 meters per second. So that's going to be the velocity on my X side. If the puck hits the ground on the floor 0.53 seconds later, so I can put that on both sides, so 0.53. So remember, time is the only one that can go back and forth. How high is the table? That means you're looking for what is your vertical distance. Okay, so remember A would be negative 9.8 because gravity is pulling it down. And VI is going to be 0 because vertically it was on the table and then it wasn't. It started falling, so it was originally not falling, so VI would be 0. That means VF doesn't matter. So we're going to use D equals VIT plus 1/2 AT squared. So VI is 0, so you can go ahead and get rid of the whole VIT thing. So distance we don't know equals 1/2 A, which would be negative 9.8, times T squared, so 0.53 squared. And we're going to get a distance of 1.38 meters. Now, what is the range of the puck? Remember, range is your horizontal distance. That's how far it goes horizontally. So that means you're looking for dx now. All you got to do is vx equals dx over t. So 6 equals dx over 0.53. And you get a horizontal distance of 3.18 meters. And that's all you had to do there. C, what is the final velocity resultant? Well, what's the resultant velocity? So that means when this puck is falling, it looks like this, okay, which is made up of both horizontal and vertical components. So resultant means you're looking for the hypotenuse and the angle. Well, you know your horizontal velocity, that's 6, it's never going to change. But we don't know this final velocity whenever it hits the ground. So remember, anytime you want to find something vertical, you just set up Daffy T. So VF is your question mark. VI is going to be 0 still. A is going to be negative 9.8. Okay, time took 0.53 seconds to hit the ground. So that means we did not care about distance. Okay, now you could have used distance from part A if you wanted to. Okay, and then left off time. That's kind of your choice on that one. So we're going to use equation number 1. So VF equals VI plus AT. So VF we don't know. VI is 0. Plus A, negative 9.8. Times time, 0.53. And we're going to get a velocity of negative 5.1 meters per second. Okay, now I know what I can do is I can bring that over here and plug that in. So now all I got to do is Pythagorean theorem and tangent. Okay, so we're going to do the whole x equals the square root of a squared plus b squared. So I'm going to do 6 squared plus my final, which I just found, which was a negative 5.19 squared. And this comes out to be 7.93 meters per second. Now your angle, now you can leave the negative in if you want to. If you're just going to get a negative angle, you're going to get the exact same value. Negative just means you're going below the horizontal. So you're going to do inverse tangent. And I'm just going to take out the negative. So I'm going to say 5.19 over my 6. And I'm going to get an angle of 40.86 degrees. And that is below the horizontal. So those are your answers right there. Number 11, what is the range of a cannonball fired at 200 meters per second at 35 degrees above the horizontal if it lands on level ground a distance away? What's the angle gives the same range? So this is a type 2. So we have our angle, which is 35 degrees. Okay, it's launched at 200 meters per second. So remember, there's always 3 things you do every single time for type 2. You want to find your Vx, your Vyi, and you want to find your total hang time, how long it's in the air. Okay, so if we want to find Vx, you're going to use cosine because Vx would be your adjacent side. So Vx equals your hypotenuse, so 200 times cosine of your angle. Okay, and you're going to get 163.83 meters per second. So there's your Vx. Vyi, okay, you're going to do 200 times sine of 35 because sine helps you find your opposite. And you're going to get 114.72 meters per second. And if you want to find total time, remember we give that equation T equals Vyi divided by 4.9. So take that 114.72 divided by 4.9. And there's the bell. And you get 23.41 seconds. So I always do those 3 things every single time. So it says how far horizontally does it land? So remember part A, you're going to do Vx equals dx over t. So Vx is 163.83 equals dx, we don't know. Time is going to be our 23.41 seconds. So multiply both sides by that, and you're going to get a horizontal distance of 3,835.26 meters. Now part B says, what other angle would have the same range? If the angles add up to 90, they'll land in the same spot. Okay, so that means the other angle would have to be 55 degrees. Number 12, a soccer ball rolls off a cliff that's 110 meters high. Okay, this is a type 1 problem again. So what I'm going to do is I'm going to set up my T-chart. So X, Y, so we're going to do Vx, dx, and T. Okay, and we're going to do our Daffy T on the right side. It rolls off a cliff 110 meters high, so that means you're looking for Well, we don't know what we're looking for yet. That's just our height. So that's our vertical height. So it's going to go on our right side. So negative 110 meters. So the reason why it's negative is because you're falling. How long does it take to reach the bottom of the cliff? That means you're looking for time. Okay, so time is on both sides, but I definitely don't have enough on the left side to do that. So A would be negative 9.8. Okay, VF, we don't know. Okay, so VI, though, is going to be 0 because it wasn't falling, so VF doesn't matter. So we're going to do the whole D equals VIT plus 1/2 AT squared. And since VI is 0, we can go ahead and get rid of that. So negative 110 equals 1/2 A, which would be negative 9.8, T squared. Okay, so divide both sides by negative 4.9, and don't forget to square root both sides to get rid of that T squared, and you get a time of 4.74 seconds. B, how far does the soccer ball land from the base of the cliff if the horizontal velocity was 5? So now we know our Vx is 5, and now we know our time. So we're just going to do Vx equals dx over t. So velocity is 5. Dx is going to be over, so we're going to look for dx, and our time is going to be 4.74. So multiply both sides by 4.74. You get dx of 23.7 meters. Okay. Only got a few left, so 13. What is the maximum range for a golf ball that's driven at 25 meters per second and lands at the same vertical level? Okay, so basically we're looking for max range. So remember, max range, the best angle is 45 degrees. Okay, and we're driven at 25 meters per second. So we're going to go ahead and we're going to do our Vx, or Vyi, and our time. So Vx is going to be 25 times cosine of 45. You're going to get 17.68 meters per second. Vyi is going to be 25 times sine of 45. But anytime you have an angle of 45 degrees, remember it's perfectly in the middle. So that means these answers are going to be exactly the same. So that's okay. And then your time is going to be Vyi divided by 4.9. So 17.68 divided by 4.9. And you're going to get 3.61 seconds. Okay, so looking for max range. So we're looking for horizontal distance. So Vx equals dx over t. So 17.68 equals dx over your time, 3.61. Multiply both sides, you get dx of 63.82 meters. There's your answer there. 14, what is the max height of the golf ball from the previous question? So remember, height is vertical. So that means you're looking for Daffy T. So distance would be your question mark. A would be negative 9.8. VI is going to be 17.68. And now VF is going to be 0 because remember the ball has to stop at the top. We're talking about purely vertical. Okay, so it has to stop at the top. So that means time did not matter. So you're going to use equation number 5. So VF squared equals VI squared plus 2AD. So 0 equals 17.68 squared plus 2 times negative 9.8 times D. Okay, move that 17.68 squared to the other side. It becomes negative, and divide both sides by negative 19.6. You get a distance of 15.95 meters. Last one, draw a P versus T graph, V versus T graph, and an A versus T graph for projectile motion. Okay, so we're just going to look at basic projectiles. Okay, so basic launching things like this. So a P versus T graph. Okay, so we're going to have a position versus time. Okay, this is literally just what a projectile looks like. So position versus time graph isn't very hard. It just looks like a projectile. Okay, now if you're doing a V versus T graph, so V versus T graph. Okay, you have a positive velocity and you have a negative velocity. Probably should have brought that down a little further. Okay, so we'll kind of clean this up a little bit. Okay, so when you launch something, its velocity is the highest at the bottom. Okay, when you launch something, it's going to start very fast and start to slow down as it gets to the top. So it starts off with a high velocity. I'm going to use a different color here. It starts off with a high velocity up here, and it starts to slow down. So remember, your x-axis is 0. So it's going to start going towards 0. And then remember, when it reaches the top of that projectile, it's going to stop. So right there is where it stops. And then once it starts going back down, what happens is it starts to speed back up in the negative direction. So now you're going away from 0 in the negative direction. Okay, so that's what a V versus T graph looks like for a projectile. Okay, then an A versus T graph. A versus T graph is pretty easy because remember A is always negative 9.8 meters per second squared. So if you had an A versus T graph, okay, so remember A, so this would be 0, this would be positive, this would be negative. It would always stay at negative 9.8. Okay, so nothing ever changes there. And that'll end that one.